We've been working with Amazon Twitch quite closely, and if you kind of look at with esports or at least user-generated content, it's mapping to kind of bringing to surface some different problems that we'll talk about a little bit here. I've got about 20 minutes, so we won't get too deep into anything, but if you have questions or you want to have more discussion, we do have a booth here and several representatives, so we welcome the opportunity. So I'm going to go through, as I said, kind of the market challenges and our perspective that when you look at these challenges, you can kind of break them into two pieces and discuss how we believe these challenges can be addressed. And we believe that hardware acceleration fundamentally is required when you start looking at live and user-generated content. And as a result of that, I'll talk about when you understand how we sort of split the problem, you'll understand why we kind of look at it in a high quality and high density kind of perspective. And I'll talk about kind of what we're doing in both of those areas. And on the high density front, this is kind of a newer area for us, so I'll highlight that. But I think fundamentally, at a 1,000-foot view, the challenge when you start looking at many of these live user-generated applications, there's kind of two big problems. One is your CapEx is massively growing, and when you look at average revenue per user, it's not growing proportionately. And then you look at OpEx, and when you start looking at the ingest and egress from a CDN or bandwidth perspective, and the volume, CDN costs and bandwidth costs are really growing significantly. When we look at where we are today and look at many marketing reports, we can see that fundamentally, you know, we're kind of getting into 2020 here, and we're at really the cusp of live streaming. And we're seeing, as we're a semiconductor company, we're involved typically in many early deployments, early discussions, and we're seeing, especially when you start looking at the amount of activity going around with CDN, but also edge computing. I think that with low latency and creating interactivity, all of a sudden new use cases are emerging, and that's going to really drive much of this live curve. And you can see that, you know, within probably the next 3 to 4 years, you know, these reports are always debatable, but I do think that live is definitely on a huge growth curve, and at some point from a volume and application perspective is definitely going to cross over file-based or VOD. Now, from a problem perspective, we like to look at it from our perspective a little bit differently, that if you're Netflix fundamentally and you've got lots of time to process any one file or any one stream, you can serialize essentially your workload, versus when you start, you know, you need to do things in real time, or in some cases faster than real time. This whole concept of do everything in software, SDN, network function virtualization, it sounds great, but fundamentally it doesn't scale well. And so when I talk about kind of Netflix versus user-generated content, you know, you can start to when you think about how networks are set up and how they're sort of generally asymmetrical in nature. And so very few inputs, lots of outputs. CDNs have been well deployed, but there's a whole new challenge that comes along with live content and user-generated content. So they're sort of two stacked problems. One is live, because you've got a limited preset time you need to process in, and the other is user-generated content rather, which is really now the end user becomes a broadcaster. Think of the amount of smartphones. Everyone now essentially becomes a broadcaster. what we, as we've spoken to many customers, especially in places like China, where the volume of people, and it's really a mobility first world, what we see is, if you profile, there was a book, I don't remember who the author was, but there's this book called The Long Tail. And essentially, if you profile your workload, then in many cases it kind of fits into that 80-20 rule. That 20% of your content on this axis is the viewership. It's the data that's created or the data that's generated from a very small number of channels or streams. But you have this significant long tail of content that really, each of these presents itself as a different problem. One is, this is bandwidth issue, cost per bit. That's what I'm most concerned about in this area. And on the right side, it's really a density story. It's cost, area, and power per channel. That I've got lots of these channels. Each one of them in and of itself does not generate a lot of bandwidth or usage, but there are lots of them. And so when we look at many customers and when they profile their workloads, it fits into this. And we don't think that any one solution is fundamentally, or any one codec for that matter, is fundamentally going to be able to address all of these. That over here, this is most likely where you're going to deploy something like AV1 or HEVC earliest, because this is where you're most sensitive to your bandwidth. And these are also your most popular, therefore quality of experience, quality of service are going to matter most in this area. Now over here, if you have 5 people on average in a live stream, if you look at Twitch, there's many use cases where there could be 6 users watching an active stream. That's where you're going to want your highest density. Therefore, something like 264 most likely is going to give you your best economical footprint. When we look at this is ultimately how, from a solution standpoint, we're trying to deploy and create solutions for that. So when we talk about, as we're an FPGA company, and we have FPGAs inherently are programmable. We have traditional fabric. I'm not sure how many people are familiar with what an FPGA is. Maybe show of hands. All right, there's a number of people here, which is nice to see. Many of you is probably from school, but so FPGAs are fundamentally programmable in nature and reprogrammable. And so as new algorithmic improvements come out, if there are new codecs, we've been working with, and we are showing it here, we've been working with a company, Vnova, for a number of years now, and the technology that they've brought to market and now is in the process of being standardized as LC-EVC. These are the types of things that you can deploy rather quickly. FPGAs are similar in areas where you would deploy, say, software, where you're ultimately trying to get your best compression efficiency. So the best video quality at the absolute lowest bit rate, and not necessarily where you care most about your cost, area, and power per channel. So I'll talk a little bit about this left side first. One of the challenges as we've tried to migrate from 264, and if we kind of put HEVC's patent or royalty schlemazel, if you will, a bit to the side, one of the challenges is that as the market moved to software and you implementing things like X264 or X265, typically what happens is you've got a number of presets. Everybody ultimately would love to use the absolute best compression efficiency. The challenge always is that you start trading throughput, frames per second, for quality. And when we, which is fine in a VOD sense, but if we look at live applications, fundamentally it's 30 or 60 frames per second. So fundamentally what we end up doing is clawing back throughput for the purpose, but in the process, we're giving up bandwidth or compression efficiency. And so what ends up happening is, in many cases, you move to HEVC to get compression efficiency, yet in the process, you're starting to give that up to get throughput, and you're challenged. So from a Xilinx perspective, if we lock to, in various codecs, if we lock to a similar profile where we believe that it's more optimal for live, what we can demonstrate is a significant throughput advantage. And with this throughput advantage, you're also getting a cost, area, and power. Now, this isn't to say that when you're looking for high-density solutions, this is something you would go towards, but absolutely, there is a advantage you can realize with an FPGA and its programmability. I'm not going to go through this in detail, but the point here is with a single, with an FPGA, because it's programmable and reprogrammable, we can support many different codecs. And I'm not even showing or representing here all of the various things that we could support. We just had a conversation with someone about JPEG 2000 and kind of feeding a contribution stream in, and then we could decode that and implement a different encoder from a distribution standpoint. As you can see here, we can, I'm not listing MPEG-2, but we even still support MPEG-2 as a legacy, because we still see that with some cable. But you can see here also that with one of our partners most recently has released an AV1 implementation. And so you can dynamically scale and change any of these codecs on the fly. We have implemented an infrastructure where changing these through a standard FFmpeg media framework is something you can do. So you don't need to be an FPGA native programmer to reap the benefits that we can bring to bear. As I mentioned, we support standards like VP9 and, as I mentioned earlier, LCEVC with our friends at VNova. One of the things that from my perspective, I find extremely exciting about something like this is that when you look at the performance that we can see with this implementation. This is actually taken a screenshot from a demo app that's streaming, and I'm showing here 1080p 30 at 950 kilobits per second, and this includes the audio, and I can show this to you at the booth as well. And so it's these types of things that you can implement in a programmable nature and do this dynamically, and that same infrastructure can be in a standard Koch server, where in one scenario you've got some percentage, maybe your most popular, you're looking at implementing AV1. In another, you've got some content where you need to distribute, say, over a 2G or 3G network. Something like the VNova LCEVC that's the kind of technology that you'll be able to distribute HD over any network. Now there is this other side of the workload where cost, area, and power per channel is critical. And there are even applications where we see that may fit into just one of these sides, like something like Safe City or Smart City is one of those applications where, you know, a surveillance camera might not have anybody watching. You might be using machine learning to intelligently monitor that channel, or even in some broadcast scenarios where you're not actually looking, you're looking for potentially quality, doing quality metrics or management. But in these scenarios where you've got a significant number of channels, you're very sensitive to, as I said, your cost, area, and power per channel. we do have a growing ecosystem of partners have been releasing standard PCIe COTS cards. These, again, can be supported through FFmpeg, much in the exact same manner as the other IP that I was showing earlier. And these vary in cost, area, and size and density. They can support 264 HEVC. Depending upon the card, you can support legacy codecs like MPEG-2 as well. There is also the ability to support even standard image processing. So we've seen applications where you've got, say, a standard 264 coming in. You may want to decode that and transcode that to a still image, which then may be shipped to a different server for the purpose of using machine learning to monitor that channel. So we do have the ability with programmability to support many of these different standards. And as I've sort of been talking about here, any of these solutions are supported through a standard framework like FFmpeg. And so in many cases, we see not only new codecs, but new use cases. So where you may want to have some mid-level processing doing, say, multi-channel compositing, or do logo overlay, OSD, things of that nature, we have various IPs that are available and that you can add or leverage from the standard FFmpeg library. And utilizing this looks exactly the same or very similar to what you would be used to using with the standard, say, libx264, libx265. The difference in this scenario is your command line would really just change a few specific parameters. And so with that, that's the quick and dirty overview. As I mentioned, we do have and recently announced with several partners, Boston, VNova, and even Supermicro, that we have a new chassis. This is a standard COTS server, rack mountable, and we've got a live demo where we're showing HEVC at extremely high quality, and we'd welcome you to come over and check it out. So with that, thank you very much.